The next time an electric bill rises, the reason may not be limited to the lights, appliances, or air conditioning inside the home. Part of the pressure may come from equipment most customers never see. Transformers sit throughout the power system. Some are small enough to appear on utility poles. Others are large machines inside substations, linking power plants, transmission lines, neighborhoods, factories, data centers, and homes. They are becoming harder to obtain, more expensive to buy, and slower to install. That matters because the United States is using more electricity at the same time the grid needs more equipment to deliver it. Data centers are expanding. Factories are connecting to the grid. Renewable projects need access to transmission. Utilities are replacing older infrastructure. Homes and businesses are using more power. Electricity does not reach a household simply because it exists somewhere on the system. It has to move through the grid, and the grid depends on transformers. That makes this shortage part of a visible household problem, rising electric bills. Transformers are not the only reason electricity prices rise. Electric rates also reflect fuel costs, generation, transmission, distribution, weather, taxes, and regulation. But transformer shortages can add another layer of cost pressure. When equipment becomes more expensive, when delivery times stretch, and when utilities spend more to maintain or expand the grid, those costs can eventually become part of the rates paid by customers. Over time, they may show up in the bills paid by families, retirees, small businesses, and middle-class households. In May 2026, EIA forecast that U.S. electricity demand would rise 1.3% in 2026 and another 3.1% in 2027. Rising demand places more strain on the system that delivers power. EIA also forecasts that residential electricity prices would rise 5% in 2026 and continue, rising in 2027, though at a slower pace. For households already dealing with higher food costs, rent, insurance, transportation, and debt payments, electricity is not an easy expense to avoid. Heating, cooling, refrigeration, lighting, internet access, and basic home power are part of daily life. That is how a supply chain problem inside the grid can become a budget problem outside it. The transformer shortage did not appear suddenly. According to the Department of Energy, distribution transformer lead times were typically 3 to 6 months in 2019. By 2023, those lead times had stretched to 12 to 30 months. Between 2020 and 2022, DOE said average lead times to purchase distribution transformers rose 443%. Equipment that utilities once planned around in months now may require planning around in years. Transformers are essential because they change voltage so electricity can travel efficiently and safely. Large transformers help connect generation and transmission systems. Substation transformers move power through the grid. Distribution transformers bring electricity down to the level homes and businesses can use. When transformers are in short supply, projects can be delayed. New power plants may wait longer to connect. Substations can take longer to upgrade. Housing developments may face service delays. Data centers and factories can add pressure to planning queues. Utilities can face higher costs when older equipment must be replaced. The effect is usually not immediate. It does not mean every household sees a sudden increase the next month. The pressure moves through the system. A utility needs more equipment. That equipment costs more, delivery takes longer, projects become more expensive. Grid investment rises. Then, depending on regulation and rate cases, those costs may be recovered through customer bills over time. That is the economic chain: equipment shortage, higher grid costs, utility spending pressure, possible rate increases, and household budget impact. In May 2026, Reuters Events reported that transformer shortages were holding back U.S. power infrastructure deployment as demand from developers and data centers outpaced supply. The same reporting cited Mackenzie data showing that U.S. demand for generator step-up transformers rose 274% from 2019 to 2025. Demand for substation power transformers rose 116% over the same period. Those figures show that the shortage is not limited to one project, region, or company. It is a wider pressure point in the power system. Generator step-up transformers help connect power generation to the grid. Substation transformers help move electricity through the system before it reaches local communities. When demand for that equipment rises sharply, utilities and developers compete for factory slots, imports, materials, and skilled labor. Reuters Events also reported that some high-capacity transformers have queues stretching up to 4 years. A 4-year queue may not sound like a household issue, but it becomes one when grid costs rise faster than expected, projects are delayed, and utilities need to spend more to meet demand and maintain reliability. The Department of Energy has described distribution transformers as the fundamental building blocks of the electric grid. That description is important because it shows why this is not a niche industrial issue. The grid is not one machine. It is a network of machines, and transformers are among the pieces that allow the rest of the system to function. DOE has identified several confirmed causes behind the shortage. There are material shortages involving grain-oriented electrical steel, aluminum, and copper. There are workforce constraints. There are component supply chain challenges. There is also a less visible problem: too many transformer designs. DOE said it identified more than 80,000 distribution transformer varieties nationwide. Manufacturers are not simply producing one standard box at massive scale. Utilities often need specific designs, specifications, and configurations. That makes production harder to simplify and harder to expand quickly. The pressure is building from both sides. Demand is rising because the country needs more electricity infrastructure. Supply is constrained because the equipment is specialized. Materials are tight, labor is limited, and production cannot expand instantly. This fits into a larger pattern in the cost of living. Many household bills are tied to systems consumers rarely see. Gas prices are linked to refineries, inventories, and crude markets. Grocery prices are linked to fuel, freight, labor, weather, and supply chains. Rent is linked to housing supply, construction costs, interest rates, and local demand. Electric bills are linked to power generation, fuel costs, transmission lines, substations, transformers, regulation, and utility investment. Consumers see the final bill. The pressure often begins much earlier. In February 2026, EI reported residential average revenue at 17.65 cents per kilowatt hour. That was 7.4% higher than February 2025. BLS also reported that electricity prices in the Consumer Price Index were up 6.1% over the 12 months ending April 2026. These numbers describe a bill that is becoming harder for households to absorb. A 5% increase in residential electricity prices may not look severe by itself, but families do not experience inflation one category at a time. They experience it as a stack of costs. Electricity rises, insurance rises, food remains expensive, rent or mortgage payments stay high. Car payments, repairs, and interest costs continue to take a share of income. That is the middle-class squeeze. A household may not know what a generator step-up transformer is, but it knows what happens when the monthly utility bill leaves less room for groceries, savings, debt repayment, or emergencies. Data centers are part of this story, but the point should be handled carefully. They are one source of growing electricity demand, especially in regions where large new loads are connecting to the grid. They are not the only source. The verified data also points to factories, electric vehicles, renewable projects, grid modernization, and aging infrastructure replacement as part of the pressure. The accurate conclusion is not that AI alone is raising electric bills. The more precise conclusion is that electricity demand is rising from several directions, while the grid equipment needed to support that demand is already under strain. Data centers can make the issue more urgent in some regions because they require large amounts of power and fast connection timelines. But the grid problem is broader. NERC has warned that large loads, including data centers, create forecasting and planning challenges. In regions such as Texas, PJM, and parts of the West, planners are trying to determine how much demand will actually materialize, when it will connect, and how the system should prepare. That uncertainty has costs. If utilities underbuild, reliability risk can increase. If utilities overbuild, customers may eventually pay for infrastructure planned around demand that changes, delays, or does not fully appear. This does not mean blackouts are guaranteed. It does not mean bills will rise only because of transformers. It means the system is under pressure, and that pressure can become financial. Manufacturers are responding. Reuters Events reported that Hitachi Energy, Siemens, GE Vernova, Hyosung Hiko, and WG are investing in U.S. grid equipment manufacturing capacity. That shows the shortage is recognized by industry. But expanding manufacturing takes time. Factories must be built or upgraded. Workers must be hired and trained. Supply chains for copper, electrical steel, aluminum, and components must support higher production. Even as supply expands, demand may continue rising. Reuters Events also reported that current manufacturing expansions may not fully resolve the U.S. supply-demand imbalance within 5 years. That is a warning about timing. The grid needs equipment now. Manufacturing capacity expands slowly. Demand continues to move. That mismatch is where cost pressure develops. For households, the impact is indirect, but real. Drivers care when gasoline inventories tighten because pump prices can rise. Grocery shoppers care when diesel costs raise freight expenses because goods become more expensive to move. Renters care when housing supply is tight because constrained markets can push rents higher. Electric customers have a reason to care when grid equipment becomes scarce because the cost of maintaining and expanding the power system can rise. Electricity is embedded in daily life. It powers heating, cooling, cooking, schoolwork, medical devices, phones, and internet access. For retirees, it affects fixed monthly budgets. For small businesses, it affects operating costs. For local communities, it affects the pace of new housing, commercial development, and industrial projects. A transformer shortage does not sound like a household story until the cost reaches the bill. The current reality is that the U.S. grid is trying to expand and modernize while a critical equipment supply chain remains strained. Transformer demand has risen sharply since 2019. Lead times have stretched. Prices have increased. Electricity demand is forecast to rise. Residential electricity prices are already under upward pressure. The final impact remains uncertain. It will depend on how quickly manufacturers expand capacity, how utilities manage procurement, how large load demand develops, how regulators handle rate cases, and whether material and labor constraints ease. The transformer shortage is not the only reason electric bills are rising, but it is one of the hidden cost pressures inside the grid. As the power system is asked to do more, the equipment behind that system becomes more important, more expensive, and harder to ignore. For ordinary Americans, the future of the electric bill may be shaped not only by how much power they use, but by how much it costs to build and maintain the grid that delivers it.